All right, it's finally time to get rid of this pesky balloon program that won't compile. It's actually been so annoying that this is just sitting there all red and angry. So let's actually fix it in this example. Let's open up the balloon program. And you can see here that there's a graphics program that presumably has something to do with balloons. And what's the reason that this is not compiling is, well, let's look at this first private instance variable at the top here. It's called red balloon, and what type is it? It's a balloon. And if I scroll over this, it'll see, hey, I don't actually know what a balloon is. So what are we actually going to do in this example is write the class called balloon. Let's go ahead and start doing that. So I'm going to move this over a little bit. Let's do new class. I have to call it balloon, and it has to look exactly like this one over here, 2 L's, 2 O's. And I'm going to leave this as a class. And let's open it up. If you remember, there's a little trick so that I can kind of look at these two tabs next to each other. So I'm going to click on here, move tab to a new window. There we go. And now it's time to write the balloon class. Now, just because what I'm given is a graphics program doesn't mean we aren't going to follow the same 3 steps of creating a class. So we're always going to start with step 0, which is our method signatures. We know that our instance of the balloon class in this graphics program is called red balloon. So anytime I see the line red balloon dot something, that actually means that that's going to be a method that I need to write of the balloon class. So let's scroll through in here until I see a red balloon dot something. Looks like I've already seen one here. Here's red balloon dot add air. So let's do public. This is going to be a void method because it's kind of on a line by itself. Void add air. And it does look like it takes a parameter. And this looks kind of crazy here, but this is really at the end of the day just a number. I know because I'm multiplying in Math.random that this actually has to be a double. So let's do double amount. It's going to be the amount of air that I'm adding in. Don't be fooled by this red circle. It's not a balloon. But what is a balloon is here, red balloon dot get radius. So let's do public. That probably returns a double get radius. Looks like I have one right here, red balloon dot is popped. So let's do public. Now the question is popped? If I asked you, is my balloon popped or not, isn't the answer to that kind of yes or no? Which means that I'm actually going to use a type here we haven't used before. If you remember, we learned the other day that there are 3 special types in Java called primitive types. These are kind of the base types in Java. Those 3 primitive types are int, double, and one we really haven't seen before called Boolean. Booleans are the idea of true and false, or yes and no. So this method here is actually going to return a Boolean. And it looks like that doesn't take any parameters. Here's my constructor, right? Doesn't look like it takes any parameters, so I think that's good. And there's actually a few other methods hiding in this one down here. Here's get radius. Get surface area is going to be one of them. Public double get surface area. And there is a get volume over here. It's kind of going off the side of my screen. So all the way down here, public double get volume. Okay, those are all of my method signatures. So I'm going to go ahead and actually close out of the balloon program for now. We don't really need it anymore. And let's think about step 1, which is my private instance variables. What private instance variables does the balloon class need to be able to track everything that's important? Well, it looks like if I'm adding air and I need to be able to give radius, surface area, and volume, I kind of need some sense of how big the balloon is. And there's a couple ways I could actually store that. I could store the volume itself as my private instance variable, or I could store the radius and then use that and a little bit of math to get the other 2. I think that's what I'm going to do. So let's do private double radius. And that kind of answers the idea of adding air, getting the radius, surface area, and volume. Now for this last one, I need to be able to say whether it's popped or not. So I think I need to store that in the class as well. So it's going to be private. That type is going to be a Boolean, and I'm going to call it popped. All right, step 1 is done. Let's do step 2. Let's fill in all of these methods with code. What's the job of the constructor? It's to initialize my private instance variables, which means in here, I need radius equals and popped equals. Now, what is my radius when I first pull a balloon out of the package? Hypothetically, it should be 0. And have I popped? Hopefully not. So I'm going to set this to false. And false is a special word in Java, right? True and false are both Booleans. So if you type it correctly, it should be all lowercase, and it turns this kind of little blue color in BlueJ. Let's skip add air. This is actually the most complicated out of all of the methods. I think there's a lot more that are more straightforward. So let's do this one last. Get radius. I have the word double here, which means I need to return something. And what I'm returning is the radius. Same thing here, is popped returns a Boolean, so I need to return, and I think I just return popped. Now is where we get a little mathy with this. You were wondering, why are we doing this example? Well, we're doing math in Java. What shape would you say a balloon is? And if I had to actually say accurately, it is kind of like an oval, like ellipse sort of deal. That math is way too hard. I don't want to deal with that. So what we're going to do instead is we're going to treat our balloon like a perfect sphere. Does anyone actually remember the formula for the surface area of a sphere? Probably not. It's been a while since geometry class for some of you. So I'm just going to tell you. The surface area of a sphere is 4 pi r squared. So I think we can do this in one line. Let's return 4 times. You're wondering how you get pi. It's actually capital M Math.pi times, how do I do r squared or radius squared? Well, I can do Math.pow radius 2. I could have also done radius times radius here. Sometimes doing Math.pow, if you're just taking something to the second power, is not all that useful. But either way is totally fine. And the volume, anyone remember what the volume of a sphere is? It's actually 4/3 pi r cubed. So let's return 4 over 3 times Math.pi times Math.pow radius 3. There is one glaring issue with what I just did. And it's actually at the beginning of this line. See if you can spot the issue before I say it. 4 divided by 3 in this class. What type is 4? It's an int. What type is 3? It's also an int. When I do 4 divided by 3, that means I'm doing int divided by int. I need to get an int back. So this is actually just going to be 1. So there's a couple ways you can fix this. I can do 1.0 times that, right? I can do 4.0 on the top. I can do 3.0 on the bottom. So I'm usually a fan here. I'll do 4.0 on the top, but any one of those would have worked. All right, now let's deal with adding in air. When I add air, I'm adding some amount. So what I'm really changing kind of directly or adding directly is some new volume of air is getting added in. So this amount would be in like liters or something like that. So I can't directly change the radius with that. I can't just say radius plus equals amount. It's not how much the radius is changing. It's actually how much the volume is changing. So let's do this. Let's say double volume equals get volume. Am I allowed to use a method in the class that I'm currently in right now? Yeah, I totally can. Then what's happening is volume plus equals amount. Again, we learned that shortcut the other day. Now, this is the annoying part, is that what I'm storing as a private instance variable is not the volume, it's the radius. So what do I actually have to do? I need to change this so that my radius is also updated. And to do that, we got to do a little bit of math. We know that my volume is actually 4/3 pi r cubed, right? And that is equal to my volume. Now the question is, how can I actually change this equation around to get it in terms of the radius? Well, first, don't I have to get this whole term kind of on the other side? So I can have r cubed equals 3 over, we'll do it like this, 4 times pi times v. And then all I really need to do is take a cube root of that to get r equals. Now let's think about how this works. Let's say radius equals, and I'm just going to type exactly this. Now, I have one problem, which is how do I actually take a cube root? There's got to be some sort of math.cubed root or something like that if there's a math.square root. But let's try to use what we already know. Can't I actually rewrite a cube root as a power? In fact, a cube root is just taking something to the power of 1/3. So let's do Math.pow. And I'm going to type kind of exactly what I've got here, which is 3 over parentheses. Let's do 4 times math.pi. Those parentheses are really important, not just because this is the denominator, but also math.pi is a double, which by multiplying it by 4 will make this a double, so I'm no longer doing integer division once I do that. Times volume, and I'm taking that to the 1/3 power. Now, something about this line should make you a little uncomfortable, and it's that I just wrote 1 divided by 3 here. What's 1 divided by 3 in this class again? It's 0, which means I need to do 1.0 divided by 3. Remember, you've got to be careful about when things like this are happening. Now, we've kind of dealt with adding air and how it will affect the volume or the radius, how much air I have. But there's one thing in this class that we haven't really touched, and that's the idea of, has my balloon popped yet or not? If you think about when a balloon typically would pop, like in the real world, it's at some level I've added too much air. And each balloon would really have a different level for that, kind of depending on how strong the balloon was or something like that. And that's actually like a measurable quantity for pretty much every balloon. So let's actually do this. We're going to make a limit for how much air we can add in. And if we actually go above that limit, we're going to say that the balloon has popped. So to do that, let's make this limit be a constant in our program. We don't have to do this, but it's typically good practice when you are adding in some sort of number that you're going to refer to in your program that's not going to change, to make it a constant. So let's do private static final double. I'm going to call it limit equals, and we're actually going to put 8 million, which sounds like a lot, but we're doing that because this is actually at some point going to be related to the pixels on your screen, and there are a lot of them. So now that I have this limit, let's go down here. When have I popped the balloon? If my volume is greater than the limit, what should happen? Well, popped is now true. And what is my radius once I've popped the balloon? It should be 0. And we have one more thing to fix, which is that I actually shouldn't be able to do any of this. I shouldn't be able to add air at all if my balloon's already popped. So when should I be allowed to do this is when my balloon is not popped. I think I have one more if statement right here, which is if popped equals false. If I have not yet popped my balloon, then I can do all of this. And I don't actually need an else here because what happens in the case where I try to add air to a pop balloon is actually nothing. So let's go ahead and compile this. You might have to actually add a space to your balloon program somewhere to get it to recognize you finished the balloon class and then compile that. And let's go ahead and try to run the balloon program. And let me tell you how it works because it's not super clear at first. For the balloon program, you get to, on your screen, click and hold, and you'll notice it'll start blowing up a balloon. It's a little loud. And if I let go, it'll tell you the final radius, area, and volume of that balloon. So let me do another one. What's going to happen if I keep holding for too long and actually add too much air? Let's see. Again, I would turn your volume down. Oh my gosh. And it actually ends telling me the radius, area, and volume are 0 because, of course, our balloon popped. Now, what was the whole point of this example? Was to practice some math and also a little bit to practice the process of creating a class because that's going to be relevant all year. Let's do a little bit of a review of the math methods because after this, we're actually going to move on to the next topic in our unit, which is strings. So there were 4 math methods that I said you had to know. We've used one a lot in this program. It's Math.pow, which takes a power. There's also Math.sqrt, which does a square root. There's Math.random, which we've used a bunch already at this point, the random numbers program, the random circles program. And there's also Math.abs, which we haven't really used that much. This is just an absolute value. So these are all the math methods you have to know. In the next video, we're going to take a closer look at strings. That's actually the second topic in this unit, and we're going to learn about the string methods that you're going to have to know.